Hello students, welcome to the class of chemistry. Today's topic is some basic concepts of chemistry. I will discuss few points with you regarding nature of matter in this class. Students, as you have studied earlier about this in your previous class, I would like to further discuss few more interesting facts. Before the discussion about the topic, I would like to share some learning objectives. These are concepts of different states of matter and difference between elements, compounds and mixture. Students, do you know what is matter? Wonderful, you know the answer, that matter is anything that has mass and occupies space. Very good. Our universe is made up of matter and energy. Each and everything that we see around us is matter. You may know that the basic constituent of matter are atoms and molecules. You know how many states of matter are there? Wonderful, wonderful. You know the answer. These are three states of matter: solids, liquids and gases. They are classified on the basis of force of attraction in between the molecules. Dear students, you can see in the picture, in solids, particles are tightly packed. In liquids, the particles are close to each other but can move. However, in gases, the particles are far apart as compared to those of solids and liquids, and their movement is easy and fast. Dear students, as you know that we can divide matter according to their arrangements of particles, force of attraction between the molecules, volume and shapes. You know that states of matter can be converted, okay, and the particular term is interconversion of states of matter, and these three states of matters are interconvertible. They can be converted into each other by changing the conditions. What are these conditions? These are temperature and pressure. Dear students, after interconversion of states, three states, you can say three important terms arises, and these are melting point, boiling point and freezing points. So, we will discuss each and every point in detail. What is melting point? Melting point is the temperature at which a given solid material changes from a solid state to a liquid or melts. Understood? What is the important point is here? That is temperature. The temperature at which given solid substance converted into a liquid form. Boiling point is the temperature at which the substance transition from a liquid to the gaseous phase. At this point, the vapor pressure of liquid is equal to the applied pressure on the liquid. The boiling point at a pressure of 1 atmosphere, the boiling point at a pressure of 1 atmosphere is called the normal boiling point. Understood? Next is freezing point. Freezing point is the temperature of a liquid at which it changes its state from liquid to solid at atmospheric pressure. At freezing point, these two phases like liquid and solid exist in equilibrium. That is, at this point, both solid state and liquid state exist simultaneously. Okay, dear children, have you heard about gas and vapor? Yeah, there is a difference in between gas and vapor. What is that? We will discuss. Vapor represent a gaseous substance which is liquid at room temperature, but a substance which is in gaseous state at room temperature is called a gas. For example, ammonia is a gas, but on heating, water forms vapor. Now we discuss about classification of matter. There are two ways of classifying the matter. First is physical classification and another is chemical classification. What do you mean by physical classification? It means matter can be divided into, as we discussed earlier, solid, liquid and gases. And chemical classification is linked with the composition of matter. Dear students, there is a picture on your screen. You can see that matter can be divided into two parts. One is mixture and another is pure substance. And again mixture can be divided into two parts, homogeneous mixture and heterogeneous mixture. And heterogeneous mixture can be classified into two parts, one is colloid and another is suspension. Now pure substances can be divided into compounds and elements. Now we will discuss mixture and each and every word in detail. Now what is mixture? Mixture, the combination of two or more compounds or elements which are not chemically combined together and may also be present in any proportion. The constituents of a mixture do not lose their identity and properties. As we studied earlier, that mixture are of two types, one is homogeneous and another is heterogeneous. What is the meaning of homogeneous mixture? If it has a unified composition, if mixture is having unified composition throughout and there are no visible boundaries of separation between the constituents, all homogeneous mixtures are also called solutions. These constituents cannot be seen even by a microscope. Understood, dear children? Now we move on heterogeneous mixture. Heterogeneous mixture, if it does not have a unified composition throughout and has visible boundaries of separation between the various constituents, these constituents can be seen even with naked eye, and that is heterogeneous mixture. A single substance which cannot be separated into other kind of matter by any physical process called pure substance. Dear students, please pay attention on this particular word. What is the meaning of pure substance? A single substance. It means a single substance which cannot be separated into other kind of matter. Understood? And what are these? These are elements and compounds. In class 11th or chemistry, basically chemistry based on elements. What are element? What are the meaning? What is the meaning of element? Single element or elements? Element is the simplest form of a pure substance which can neither be broken into or nor built from simpler substances by ordinary physical and chemical method. It may also be defined as the pure substance which is made up of one kind of atoms. It means element, single element is made up of one kind of atom. I think so that you are very good aware of some examples of elements like carbon, like sulfur, like hydrogen. All these are the example of elements. How many elements are known at present? 118 elements are known at present, and out of them 92 have found to be present in the earth crust and the remaining have been prepared artificially in the laboratory. Or dear students, you can also prepare any element in the laboratory if you study chemistry very interestingly way with the help of nuclear reaction. The most abundant elements are oxygen, silicon and aluminium. The rest of elements are present in smaller proportions. Understood? Types of elements. There are basically three types of elements: metals, non-metals and semi-metals. You know what is the Example of semi-metal, arsenic, antimony and so on compounds. A pure substance containing two or more elements combined together in a fixed proportions by weight and can be decomposed into these elements by suitable chemical methods. Moreover, the proportions of a compound are altogether different from the constituting elements. Types of compounds. There are two types of compounds, inorganic compounds and organic compounds. Inorganic compounds are the compounds which are obtained from non-living sources such as rocks and minerals. Example, common salt and gypsum. Organic compound are the compound which are present in plants and animals. You know the example. Fats, proteins, oils, all these are the example of organic compounds. Identify the element, mixture, compound from the picture given below. Tell me, the picture of A is what? It represents element picture, and B is a compound of two same elements, and C is compound of two different elements, and D is a mixture. Wonderful. Here is one activity for you all, dear students. Classify the following as pure substances or mixtures. Separate the pure substances into elements, compounds and divide the mixture into homogeneous and heterogeneous. Examples are air, milk, graphite, gasoline, diamond, tap water, distilled water, oxygen. Can you tell me what is air? Air is a homogeneous mixture. Very good. Milk? Milk is also a mixture, but what type of mixture is that? That is homogeneous mixture. What is graphite? Graphite is a pure substance. Why? Because it is made up of element. Gasoline? Gasoline is a mixture. And what type of mixture is that? That is homogeneous mixture. Diamond? Diamond is a pure substance and made up of element. Diamond and graphite both are the allotropes of carbon. It means the constituent of this is carbon. Tap water? Tap water is a mixture. What type of mixture is? That is homogeneous mixture. Distilled water, it is a mixture? No, dear students, it is a pure substance, and that means distilled water is a compound. Don't mix distilled water with tap water. Don't be confused. One is homogeneous mixture and another is pure substance. Okay. Oxygen? Oxygen is a pure substance and that is in the elemental form. Now, move on, properties of matter. Each and everything has two properties, one is physical and another is chemical properties. Dear students, you know what is the meaning of physical properties and what is the meaning of chemical properties? Let's discuss about that. Dear students, every substance has unique or characteristics properties. These properties can be classified into two categories, physical properties such as color, odor, melting point, boiling point, density, etc. And chemical properties like composition, combustibility, reactivity with acids and bases, etc. Physical properties can be measured or observed without changing the identity or the composition of the substance. Measurement of physical properties does not require occurrence of a chemical change. The measurement or observation of chemical properties requires a chemical change to occur. The example of chemical properties are characteristics, reaction of different substances. These includes acidity or basicity, combustibility, etc. Chemists describe or interpret and predict the behavior of substance on the basis of knowledge of their physical and chemical properties. Measurement of physical properties. You know, It is necessary to measure the physical properties. Many properties of matter such as length, area, volume are quantitative in nature. Any quantitative observation or measurement is represented by a number of followed units in which it is measured. For example, length of a room can be represented as 6 meter. Here 6 is the number and m denotes meter, the unit at which the length is measured. Understood? Dear students, there are some basic physical quantities which we uses for the determination of units of different quantities like length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. You know, how can we symbolize length? The symbol for length is L and the unit of length is meter and the symbol for the meter is m and the unit of mass is kilogram and the unit of time is second and the unit of electric current is, oh wonderful, you know the answer, that is ampere, and thermodynamic temperature is Kelvin, okay, and amount of substance is mole. This mole is very important for chemistry. N is the symbol and unit is mole for the amount of substance. And luminous intensity is, unit is candela. Now we move on laws of chemical combinations. Okay, dear students, there are 5 laws of chemical combination. First is law of conservation of mass, second is law of definite proportion, and third is law of multiple proportion, and fourth is given by Gay-Lussac, that is why it is called Gay-Lussac law of gaseous volumes, and fifth one is Avogadro law. We discuss each and every one by one. First law is law of conservation of mass. This law was proposed by Antoine Lavoisier. It states that matter can neither be created nor destroyed. We can only convert one form of matter into another form, or in a chemical reaction, the total mass of reactant is equal to the total mass of products. Dear students, see, there is an example for you. There are 2 reactants, one is methane and another is oxygen, and it gives out carbon dioxide and water. If you see the mass of reactant, that is 80 gram, and the product mass is also 80 gram. It means the mass of reactants and product is always constant. It means the reactant mass is equal to the mass of product. Understood? We move on second law, that is law of definite proportions. This law was proposed by Joseph Proust. It states that a given compound always contains exactly the same proportion of elements by weight, or the same compound always contains the same element combined in a fixed ratio by mass. Like carbon dioxide contains only 2 elements, carbon and oxygen, combined in a mass ratio 3:8. Here one picture is also for you, that the tap water, whether it is from my house or from your house, it always contains 2 atoms of hydrogen and 1 atom of oxygen. So what will be the ratio? That will be 2:1. It means the proportion, the constituents of water contains 2 atoms of hydrogen and 1 atom of oxygen. Dear children, now we move on third law, and that is law of multiple proportion. This law was proposed by John Dalton. John Dalton is very important, my dear, and keep it in your mind. It states that if two elements can combine to form more than one compound, two elements can combine to form more than one compound, the different masses of one of the element that combines with the fixed mass of the other element are in small whole number ratio. Hydrogen combined with oxygen, it forms two compounds like water and hydrogen peroxide, but always in hydrogen plus oxygen gives water. How many grams of hydrogen is here? 2 gram. And same in hydrogen peroxide, the mass of hydrogen is 2 gram. It means always mass of one component should be constant. Understood? Now we move on fourth law of chemical combination, and that is given by Gay-Lussac, and that is based on what? This law was proposed by Gay-Lussac and states that when gases combine to form gaseous products, their volume are in a simple whole number ratio at constant temperature and pressure. Again, one example for all of you, that is hydrogen react with oxygen and gives two molecules of water. The volume of hydrogen and oxygen which combine together bear a simple ratio, and what is that? That is 2:1. Now dear children, we move on the last law, and that is Avogadro law. It states that equal volume of all gases at the same temperature and pressure should contain equal number of moles or molecules. Dear children, there are some questions for you for your home assignment. First question is, kindly note it down, give the 2 points of differences between homogeneous and heterogeneous mixtures. Question number 2, copper oxide obtained by heating copper carbonate or copper nitrate contains copper and oxygen in the same ratio by mass. Which law is that? Illustrated by the observation. Understood? Now, third question is, define the law of multiple proportion. Explain it with one example. Now, last question is, write 3 points of difference between compound and mixture. So, thank you dear students and have a nice day.